All right, here is the journal pages that are going to be a review of what we've done in previous lessons. So it says solving multi-step number stories. Estimate your answers before solving and use your estimates to check your answers that your answers are reasonable. So let's look at number 1. So I can see they want us to do a number model with an unknown, an estimate, answer, and then explain. So there's 4 parts to this multi-step number story. So let's read it. Number 1, 8 baseball teams are participating in a tournament. So there's 8 baseball teams. Let me change my color. Each team is bringing 18 players and 2 family members per player. All are traveling in vans with 7 people per van. How many vans are needed to transport all of the players and the family members? Okay, so the first thing that we're going to do is do the number model with the unknown. You actually could do your estimate first. So I know there's 18 players and 2 family members per player. That means the player plus their 2 family members is 3 people. So every person on the team has 3 people, themselves and their 2 family members, times 18. I can't do that in my head very quickly, so I'm going to do, my estimate's going to be 20 times 3, because I can do that easier in my head, and I know that that's 60. So right now, there's 60 people per team that are going to this tournament, but I know that there's 8 teams. So I'm going to do 60 times 10, because I could do that easier in my head than 60 times 8. And I know that that's 600. So there's 600 people going to this tournament. So there's 2 family members per player, 18 players on each team, and there's 8 teams. That's how I got that 600, because I estimated. Now, I'm going to take that 600 people and divide it by how many people can fit in each van. Now, I can't do 600 divided by 7 in my head, so I'm going to do 600 divided by 10, because I could do that easily in my head. So my estimate is 60 vans are needed to go to this tournament, to transport all of the players and their family members. You're going to need 60 vans. That's my estimate. So let's see if we're a little bit reasonable. Okay, we're going to do the same thing, but now we're going to do the actual numbers. So I'm going to write one long number model with the unknown. So I'm going to do the 18 people, the 18 players, times 3 for themselves and their 2 family members. That's where I'm getting that 3. And I'm going to put that in parentheses. That's what we did here. Then I'm going to multiply that again by how many teams there are. That's what we did here. Then there's 8 teams. So I'm going to put another set of parentheses. And then I'm going to take that total and I'm going to divide the whole thing by 7, because that's how many people per van. We did that estimate here. Equals V for how many vans. So now let's do the math. I'm going to do 18 times 3. And I know that 8 times 3 is 24. 3 times 1 is 3, plus 2 is 5. So 54. Then I'm going to take that 54 and I'm going to multiply by 8. 4 times 8 is 32. And then 5 times 8 is 40, plus 3 is 43. So now I have 432. So I'm going to erase my work here so I have some room. Now I have to divide that by 7. So I'm going to do 7 divided by 432. Now, I'm going to zoom in a little bit. Let's do blue. I know that 7 can't go into 4 because 4 is too small. But 7 can go into 43. Now, it's not a multiple, so I have to think what will get me close to that. Now, I know that 7, you could make 6 groups of 7 would give you 42, because 6 times 7 is 42, and I'm left with 1. Then I'm going to bring down that 12. I know that 7 can't go into 12 evenly, because 7 times 2 is 14. That's too big. And I know that 7 times 1 is 7. And then if I do 12 minus 7, I'd get 5. So I have 62 remainder of 5 as my answer. Now, the only issue with that is the vans hold 7 people. I can't leave those extra 5 people home, so I need to make another van come and take those 5 people. So my answer is 62 vans, which is pretty close to what our estimate was, which was 60 vans. I'm sorry if you just heard Jones drinking a ton of water. He just came back from a walk and he was quite thirsty. Okay, so what did you do with the remainder that you found? So when I divided the number of people into vans, I needed 61 vans and had 5 extra people. I can't leave those people behind. So I needed an extra van. Okay. Look back at your estimate. Does your answer make sense? Yes. My estimate was 60. And the real answer was 62. So I'd say that was pretty close. Okay, all that work for one problem. So let's do number 2. Team A raised $200 to pay for their family's ticket to watch the games. The tickets were $6 per adult, $4 per child. If each of the 18 players brings one adult and one child, how much money will Team A have left over? So let's think about this for a second. So if I'm going to do my estimate, there's around 20, I'm going to round 18 to 20. There's 20 players. And if each of them brings an adult, I'm going to do 20 times 6 in parentheses. Plus, if each of those 20 players brings one child, it's $4 a child. So you have to do 20 times 4. And then you are going to have to add those. So you would get 120, because 20 times 6 is 120, plus 20 times 4, which is 80, and you get 200. Now, if they raise $200 to pay for their family's tickets, and they need $2, I would do 200, which is the money they need, minus the $200 they raised, and you're left with 0. So according to my estimate, the team raised enough money for nobody to have to pay for their tickets. So let's see what the real answer is going to be. So I'm going to do the same thing with a number model. I'm going to take that $200 they raised, and I'm going to subtract the 18 times the cost of one adult and one child ticket. That's where I'm getting that 6 and 4. So I'm saying that I'm going to take 18 players and I'm going to multiply if each of them bought an adult ticket and then each of them also bought a child ticket. So it would be 18 times 6 and 18 times 4 equals T, the cost of the tickets. So first we have to do what's inside the smallest parentheses first. So 6 plus 4 is 10. And now I'm going to do 18 times 10. And I know that 18 times 10 is 180 minus the $200 they raised. So they have $20 left over after each player buys one adult and one child ticket. So look back at my estimate. So my estimate does make sense, yes, because I rounded 18 to 20. So really there should have been a little bit more money left over because I rounded up. So there should have been more money left over because I rounded up. Okay, this was the first page. Let's do the second page. There's only 2 more questions on this second page. Okay, so number 3. The teams wanted to raise $2,500 to pay for new equipment for next year. They have 12 boxes of souvenir programs with 35 programs per box. Each program sells for $7. If all of the programs sold, how much money will the teams have left over after paying for the new equipment? So let's highlight our important information. The team wants to raise $2,500. In order to do that, they want to sell souvenir programs. They're selling each program for $7. Now, they have 12 boxes of the souvenir programs, and there's 35 programs per box. So we're going to have to do our estimate first. So we have to figure out how many programs they have all together. That's the first thing we have to do. So if they have 12 boxes, which is close to 10, so I'm going to round down, and there's 35 programs per box, I'm going to round 35 to 40. So I would do 10 times 40. And that equals 400. So they have about 400 programs. So then I'm going to take the 400 programs and I'm going to multiply by 7 because they're selling them for $7 each. And I would get 7 times 4, which is 28. So 7 times 400 is 2,800. So if they sold all of them, they would make $2,800. Now, I'm going to take that $2,800 and I'm going to subtract how much money they wanted to raise, which is $2,500. And you get $300. So they would have $300 left over after purchasing their new equipment. So let's see if our estimate is close. So we're going to do the same thing we just did, but with the actual numbers. So my number model would look like this. It would be the 12 boxes times 35, and I'm going to put that in parentheses. Then whatever that total is, I would multiply that by 7 because it's $7 per program. And then I would subtract that by the cost of the equipment, which is $2,500, and you would get, let's say M for money left over. Okay, so let's do that math. If I did 35 times 12, 5 times 2 is 10, 3 times 2 is 6, plus 1 is 7, 1 times 5 is 5, and 1 times 3 is 3. So you would get 70 plus 350, which is 420. So there's 420 programs. You would take that 420 programs and multiply by 7, because you're selling each of them for $7. So 7 times 0 is 0. 7 times 2 is 14. 7 times 4 is 28, plus 1 is 29. So if you sold all the programs, you would make, that's a dollar sign, you would make $2,940. I would take that $2,940 and I would subtract $2,500 they need for their equipment. So 0 minus 0 is 0, 4 minus 0 is 4, 9 minus 5 is 4, 2 minus 2 is 0. So your answer is you would have 400 and put my dollar signs, $40 left over after you sold all of your programs. And yes, my estimate is close because 300 is close to 440. Okay, let's look at number 4. In baseball, the bases are 90 feet apart. When a player hits a home run, he or she runs around all 4 bases. During the tournament, players hit 9 home runs. How many total yards did the players run after hitting their home runs? Okay, so this is definitely multi-step. So let's highlight the important information. The bases are 90 feet apart. When you hit a home run, you run around all 4 bases. So this is times 4. During the whole tournament, players hit 9 home runs. How many total yards, and I'm going to put 2 underlines under yards, did each player run after hitting their home runs? Okay, so what you have to do is figure out how many feet is 1 home run, and then you're going to multiply that times how many home runs they hit, and then divide that by how many feet are in a yard. So we're going to do our estimate first. So there's 90 feet between each base, so that's kind of close to 100. And then I'm going to divide that by 4. I'm going to leave the 4 where it is. I'm sorry, not dividing, multiplying by 4. And I know that that's 400. So when you hit a home run, you run 400 feet when you run around all 4 bases. So then, if it's 400 feet per base and the players hit 9 home runs, you have to do 400 times 9 to get the total number of feet that they ran, which is 3,600. So then I would take that 3,600 and I would divide that by 3 because there's 3 feet in every yard. And I know that 3 into 36 is 12. And then I'm just going to add my zeros. Okay, so that's my estimate. So let's look at what it actually is. We'll do a different color for our number model. So you're going to do the same exact thing. You're going to do 90 times 4. So 90 is the feet per base times running around 4 bases. Then you would multiply that times 9, the home runs they hit. Then you would take that total and divide it by 3 to get how many yards. Okay, so step 1. 90 times 4. I know that 4 times 0 is 0. And then 9 times 4 is 36. So there's 360 feet when you run around all of the bases. So number 2, take that 360 feet and multiply it by how many home runs they hit, which is 9. 9 times 0 is 0. 9 times 6 is 54. 9 times 3 is 27, plus 5 is 32. So when you run around all of the bases and you hit 9 home runs, you are running 3,240 feet. So now I'm going to take, this is step number 3, 3 divided by 3,240. Now, I know that 3, I'm going to zoom in, 3 can go into 3 one time. So 3 times 1 is 3. And I'm left with 0. I'm not going to put the 0, though. I'm going to bring down the 2. Can 3 go into 2? No, because 2 is too small. So I'm going to put a 0 above the 2. Because 3 times 3 is 0. 2 minus 0 is 2. And then I'm going to bring down the next place value, which is 4. 24 is a multiple of 3 because 8 times 3 is 24. And then I'd bring down the 0 again. And 3 times 0 is 0. So my answer is 1,080. So the team ran 1,080 yards. And my estimate was correct because the answer, which is 1,080, is close to my estimate, which is 1,200. Okay, there you go. We're finished with these journal pages. Watch the next video for math boxes.